Okay, in the first grouping here, they have a table of information of approximate height and horizontal distance traveled by a football kicked at an angle of 30 degrees with an initial velocity of 30 yards per second. So the chart shows time in seconds. It shows height in yards. And you have all this information. And it has distance in yards. And it shows at 0 point, you have no height and you've traveled no distance. In half a second, it's risen to 6.2 yards high and it's traveled 13 yards. In 1 second, its height is 9.7 yards and its distance is 26. In 1.5 seconds, it's up as high as 10.5 yards and it's traveled over 39 yards. In 2 seconds, its height has now gone down to 8.7. Thank you so much. And the total distance traveled is 52. And in 2.5, perfect, that's fine, thank you. It's at a height of 4.2 and the total distance traveled is 65. So we have a couple questions to answer, and you can do it right on that paper. It asks, is the rate of change for the height of the football constant? So what I want you to do is look at the middle column and see if the distance between each pair of numbers is the same. So I'll go ahead and do that. I'm going to put this on pause. Okay. Between 0 seconds and 1 second, what's the change in height? 6.2. What's it between the half second and the whole second? 3.5. Between 1 second and 1.5 seconds? Should be 0.8. How about between 1.5 seconds and 2 seconds? It's going down, so we can use what to express going down? So negative, and what did you say? Shouldn't be 2.2. 1.8. And then what about the last group? 4.5. So what do you think is going on with this height of the ball that's being kicked? It's going up, and then it's going down, okay? So the second part says, okay, number 2, we'll look at the rate of change for the distance traveled. So that's the third column. So go ahead and figure out what the difference is in distance traveled in the third column. All right, what are you guys coming up with on that? 13. Yeah. So what does that mean? Yeah, so that for every half second it travels 13 yards. That's constant, okay? All right, so now what we're going to do is on the bottom of that sheet, you're going to graph 2 different graphs. One's going to be from the perspective of time and height, so the first column and the second column. The second graph is going to be time and distance, and that's going to be the first column and the third column. So take a moment and graph those ordered pairs. So you're going to have to do a little bit of approximation, obviously, because very few of the numbers were at whole numbers. They were all fractional or decimal parts. Okay, so all I did is, what I did here is I recreated the graphs. I probably could have spread out the time a little bit more, but I spread out the 2 measurements, the height and the distance, and I only kind of kept it towards what I was going to need to graph. So mine's going to look just slightly different in terms of spacing than yours. So what did you notice about the time and height when you graphed that? What did you see? Okay. So it didn't go straight, it curved. So at half a second we were at 6.2. At 1 second we were at 9.7. At 1.5 we were at 10.5. At 2 seconds we were at 8.7. And at 2.5, we were at 4.2. So if I connected these up, it would look something like this. Okay? And it eventually would hit down. I don't know the exact time, but eventually would hit down. Now on the other one, what did you notice about that graph?
Constant.
It was constant. So at 0, it was 0. At half a second, we were at 13. At 1 second, we were at 26. At 1.5 seconds, we were at 39. At 2 seconds, we were at 52. And at 2.5 seconds, we were at 65. So if I connected those up, you would see that rate of change is different. So basically what I've just demonstrated to you is the difference between the types of functions that we have been looking at recently, which are linear functions, because we're able to draw the information and it looks like a line, versus, not very descriptive, nonlinear functions. So functions that don't form a line. They're still a function. That means they pass the vertical line test. They're considered a function, but they're not lines. Okay? So what we want to do is kind of explore a little bit of different types of functions to see what they look like. So today, because of our kind of shortened time, we're not going to do as much as I would like to. So what we're going to end up doing tomorrow is we're going to practice you guys putting in equations into Desmos and going from there. So basically, part of your homework is simply looking at a table or some information and to determine whether it's linear or nonlinear. So when they're asking for two variables, we're looking for a rate of change. So let's talk about that and remind ourselves what we're going to be doing. So linear versus nonlinear.
Can we write this on the board?
This could be in your spiral. Nonlinear. So a linear function growth is constant, or rate of change is constant. And then nonlinear function growth or rate of change is not constant. Okay? And so we can add a little thing that graphs are not straight lines. Okay, over here, with linear functions, graphs are lines. Okay? So what we're going to look at is that rate of change. We've talked about that before. It's been a while. It's the rise over run. It's the difference in x's, or difference in y's, excuse me, over the difference in x. So you can calculate it by looking at your is your time increasing appropriately the same amount? Is your other increasing the same amount? So I'm going to give you two examples that you can look at for the linear versus nonlinear function. Jeez. So I'm going to give you two situations. We're going to look at two charts, and we're going to look at growth and rate of change and see if we can determine, just by doing simple calculations, whether we have a linear or a nonlinear function. So in the first one, we've got 2 and 50, 4 and 35, 6 and 20, 8 and 5. So what I want to do is look at each of my x's and each of my y's and see if I'm seeing something that's constantly happening. So if we look at the x's, what do I do to get from 2 to 4? Excuse me? Add 2. What about from 4 into 6? Add 2. What about from 6 to 8? Okay. So that growth was constant. Just like in the example with the football, time was constant. It was every half a second. All right, let's look on the other side. 50 to 35, what am I doing?
Minus 15.
Subtracting 15. How about 35 to 20? How about from 20 to 5? Okay. So in this case, what we see is, let me write it in a different color. As each x increases by 2, each y decreases by 15. So we say the rate of change is constant. Based on that, what would be our interpretation of this function? Linear or nonlinear? Yeah. If we have constant rate of change, then it's linear. Okay. Second set of data. 1 and 1, 4 and 16, 7 and 49, 10 and 100. So take a moment. Write it down. And do the math in between them. Homework tonight. Let's go to guided practice, page 30. I would circle this up. Page 330, sorry. Circle up questions 1 through 4. On page 331, circle up 1 through 7, and on 332, 9 through 12. Okay. And then we'll talk about different ones.
On the packet?
And this is your fifth one. That was
This is due tomorrow.
On this one, you'd have to really, this one's not going to be a very simple one to figure out. But you're definitely not going to have white wolf 2 extra 5. You're going to do all your work in tomorrow.
I didn't have
No.
So I didn't think we were going to have testing.
Just stay close.
Yeah.
Okay, I'll show you. Yeah, I'll show you tomorrow, okay?
Yeah, probably, but
It's like a wrap. No, I'll show it to you. No, it's good. It's like, and then,
okay, we'll have to
website was, but it had dropped off. All across Orange County. No, we've been through it today. It just, I think it circuits got overloaded and it just, that was it.
Okay, bye, Mr. Listener. See you Monday.
See you, Aaron. Okay. So, buddy, just look on School Loop. It'll be stuff out. Oh, let me give you one more thing.
Oh, yeah, it's cold. Hey, John, do you have a sister?
This is getting ready for the school.
That was.
So there may be a little bit more that we do, Aaron, but that for sure is the Friday homework, okay?
Wait, what's the Friday homework?
Don't worry about the Friday homework because it's only Thursday.
There's a song about stars.
I saw it. Hey. Hey. I saw it. Oh,
He cut my knee.
Okay, please do not get up and staple these packets now. We have time at the end of the period, you may do so, but. So, I'm gonna hand them out as packets. Don't worry about it, we'll get to it. And then we probably won't have time to do what I would have wanted to do if we were all set to take one packet. Yeah, and that's why they're in different directions. Oh, wait a second, there's one extra. So tomorrow, what we'll probably end up doing is we'll do some explorations on Desmos. No, no. So the reason why we are not testing today is we had an issue with the website went down for all of Orange County. So schools all across the county were trying to test today and we're not able to get on. So at this point, they kind of abandoned us going back in, and that most likely means that this scenario will happen again next week on Thursday, where we'll all have to go in and get those who were not finished get to get finished. Now, did anyone see Jack? Is he absent today?
He's absent.
Absent.
Megan, there's two.
What if you brought your book down?
Huh?
I brought my book.
That's awesome.
Yeah, me too.
I brought a dictionary to read.
That shouldn't be shocking because that was your requirement. So right now, because we're not using them, I'm not going to be counting it. But the next time we go, if you come to class unprepared, then that's a problem. So here's the gist of today. Unfortunately,